Hello everyone, you are all welcome to lecture number 979, and today's topic is treatment of industrial waste, or we can say wastewater. That is your industrial waste and treatment process. So industrial waste and treatment process, if we are saying, means it is effluent in the form of liquid, and that is water. So the water is containing lot of industrial waste, and this is global issue, very important issue. How to treat, how to purify that water, which is industrial wastewater. And once we say industrial, there are variety of industries. Some industries they are producing leather, that is tanning industry, pharmaceutical industry, textile industry, food industry, rubber industry, paint and pigment industry. There are variety of industries, and these industries they produce different type of acid and base, different type of organic and inorganic waste, and they are contaminated with water. So we have to treat water to get dispose these waste. And not only that, as you know that the fastest growing subject in the world is chemistry and chemical process, chemical industries. In 1800, we were having only few hundred products out of chemical industries, and today we are having more than 50 million products, and we are expecting by 2050 up to more than 200 million, and by 2100 it will cross 1 billion chemical substances. So with growing industrial demand, products at the same time is a big challenge of growing population also. So how to sustain growth of population, because now today that is in 21st century, means 2021, year 2021, our global population is almost 8 billion, is you can say 8 billion, and within 10 years time it will be 10 billion. So the population is also growing, and at the same time the industries production, chemical industries, their growth is also exponential. So how to sustain these all these things? And for that we have to adopt some new technologies, bacteriology, some fermentation technique, so that some of the bacteria can destroy and damage those organic materials. If hydrogen sulfide is there, it gives very bad foul odor. How to tackle that issue if it goes to river and pond? So these are all very, very important challenges of 21st century to chemists. That is the disposal of industrial waste in the form of industrial wastewater. So I will be discussing one by one, and this industrial process, and that is treatment of this waste material out of industries is very important, and it is affecting everybody. And now we have to see the economy of this waste. Sometimes it is important to convert these waste into a good material, good shape, amazing things, so that we can utilize them. For example, we have leather industry. From that we are getting some dyes or some other type of material, so we can use for coloring purpose. From sugar cane waste we can use it for some purposes to produce the paper, and then from molasses sugar industries we can convert by the fermentation into alcoholic beverages. So like that, we are making our effort with new technology, especially with fermentation technique. Fermentation is playing very important role for waste treatment, and as well as with the help of this bacteria that is called bacteriology of wastewater. So these bacteria, they are selectively destroying those bad smelling or toxic materials into non-toxic materials. So these factors I will be taking one by one. So industrial waste and treatment process is a very, very challenging job for chemist, biologist, environmentalist. And if we say the industrial waste, of course it is lot of different type of chemicals, waste material in water that is toxic to all of us. In many ways, their accumulation is creating lot of health hazard. The acid, sulfur, that is hydrogen sulfide, that is H2S, sulfuric acid, nitric acid, all these type of acidic material can even destroy lot of microorganisms which are doing their job in fermentation process to destroy a lot of waste products. They can be damaged, and also our concrete buildings, cements can be corroded, can be destroyed and damaged. So there are is a global challenge and issue how to treat and manage the industrial waste. Number one, the disposal of waste waters is of the widespread global concern. It's a global challenge to dispose of the waste waters. Industrial activities generate a large number of variety of waste products. Industrial activities means industrial growth, establishing different type of industries, and can generate variety of a number of variety of waste products, and which are generally discharged into water stream. All these waste material, organic or inorganic or mineral material, they are all discharged in water, and that water is called wastewater. And how to manage with wastewater, how to treat it, how to recycle it, streams, and the chemical and physical nature of the industrial waste depends upon the industrial processes. So once we say industrial processes, means different type of industries and what type of different processes are involved in breaking down different type of chemical substances. Some industries, they are producing hydrocarbon, where petroleum industries are there. Some are producing sulfur dioxide gas, where we are dealing with sulfuric acid, with nitric acid, so they are producing lot of acids. Where there is tannery, they are producing lot of toxic chemicals. So it depends upon the industrial process in which they originate. The problem of handling industrial waste waters is more complex and much more difficult than sewage treatment, because sewage, in the case of sewage treatment, we know that this sewage is having this type of waste material. But in the case of industrial wastewater, industrial waste substances, we don't know the type, because there are variety of industries and they are producing variety of toxic and poisonous and hazardous chemicals. So it is more complex and difficult to treat the industrial wastewater as compared to sewage treatment. That is sewage treatment, because industrial wastewaters vary in nature from organic or inorganic matter. Because this industrial wastewater, mainly it is organic and inorganic, and in most of the cases what I have seen, mostly they are organic ones, and very few where we have some textile or explosive industry or some inorganic fertilizer. There we can have some inorganic waste. Otherwise, in most of the cases, they are organic waste, and then organic matter or with corrosive, poisonous, inflammable or explosive substances. Organic compounds, however, constitute a large proportion of these wastes, which are destroyed slowly by bacteria. Actually, this is very positive thing, that a large proportion of all these industrial wastewater, they contain organic matter, organic substances, and bacteriology, that is called bacteriology, how to dispose all these wastes. There are lot of chelated waste, and where bacteria plays very important role to destroy and to change those complex toxic ones into simpler ones, so that all the toxicity is drastically reduced and destroyed. So that is taken care by the bacteria, and unpleasant odors and taste are by this bacterial action. Sometimes lot of foul, lot of bad odor is produced, and that is not acceptable, and that is also taste is also bad, is because of bacterial action to destroy all those waste in the water. Number 3, some industrial wastes are objectionable, that they should not be added to the public sewage system. So this is we have to be very careful, that some of these industrial wastes are so objectionable that they should not be added to public sewage system. It should have this separate place to collect and just disintegrate it, destroy it. It should not go to any public sewage system. So it is safe to discharge them into storm drain. Either you discharge them into storm dam or directly into natural body of water such as stream, lake and river, so that there is enough space and area to get it disintegrated. 3, some industrial waste clog H2S and acids. They are clogged, some industrial waste. All these acids like hydrogen sulfide, sulfuric acid, nitric acid, and these destroy the cement, concrete and metal. This is the immediate damage to human beings. And some poisonous chemicals may also interfere with biological treatment process by killing the bacteria or microorganisms. Here, let me tell you, here once these are involved in corrosion, in damaging our concrete structure, infrastructure, our pipe, our industrial buildings, is a serious financial loss to human beings. So because of this industrial waste water, acid and base or organic, lot of challenges are there, and we are losing lot of money. So it is very important immediately to treat these waste and to neutralize them and to convert them into usable material. So here number 4, the great variety of chemical waste produced globally in the variety of industries and factories. We have some general practices is that of storing or lagooning. This is the general practice globally, that whatever industrial waste is produced, we are storing or lagooning, and this is very good also, because sometimes if suppose acid waste is there, basic waste is there, and they are stored, and if they are reacting, they are neutralized, and in that case the waste is disposed of. And this practice serves many purposes. For example, in factories having acids as well as basic waste, it reduces the cost of neutralization, because if you have both, you can neutralize them, and after that neutralization you will get salt and water. So acidity and basicity will be neutralized. In industrial plants having waste water containing organic materials such as in paper mills, that causes reduction of BOD. So that is oxygen, dissolved oxygen is reduced in that case, and here to improve the dissolved oxygen of the water, we have to put it for aeration, or we have to treat it with alum or ferrous sulfate, so that whatever suspended particles are there, they are cleared. And dissolved oxygen plays very important for marine life, like fish, because if the percentage of dissolved oxygen is less than 4, they are in danger. Generally speaking, the dissolved oxygen in terms of ppm, part per billion, should be 6, 7, around that. And if it is below that, part per million dissolved oxygen, the fish or marine species in river and pond, they are in danger. That's why in Maiduguri, many of those who are doing fish farming, they don't understand this dissolved oxygen of water as well as pH value, acidity, and that's why a lot of fishes, especially the catfish, they are dying. So some of them, they approached me. I told them that please check your dissolved oxygen in pond, because one, the running water is there, big space. If you are checking, it will be around 5 to 7 ppm dissolved oxygen, and in that case, if you check, if it is less than 5 or 4, you have to add the water, aeration and air pumping, air bubbling, so that at least dissolved oxygen is increased in the water. So these are all very important factors of the waste water from industrial waste. They may reduce the dissolved oxygen of the water. And number 5, a general problem in industries is the disposal of waste obtained by water softening treatment. So there is also one of the general problem where we are, because nowadays lot of water treatment plants are there, they are supplying mineral water, or distilled water, or coral water. There are different names here in Maiduguri globally. Now potable water, they call it drinking water, is having a plant, water treatment plant, and there they are using the softening treatment, and that is lime surges, maybe lagoon and settle, or they may be dewatered and calcined for reuse. Brine used in generating ion exchange plants is best stored and then added to stream by controlled dilution. Number 6, activated sludge process. An activated sludge process is used to treat the waste when industry is using organic raw materials, organic raw materials, and this process is very successful in waste from tanneries, meat packing plants, milk processing plants, rendering plants, etc. The tannery waste may be treated by sedimentation or by filtration. Beverage wastes are subjected to trickling filters to reduce BOD and remove most of the suspended solids. So with this I will stop. Thank you very much for watching the lecture.